Washington, we have a problem. A nuclear-free Korea is on the agenda for the upcoming Kim-Trump playdate. In the meantime, the North's apparently just gonna test a new reactor while they still can. A newly finished nuclear reactor in North Korea's Yongbyon complex has reportedly come online after satellite images show its smokestack releasing emissions. The North claims the reactor is meant to produce electricity for civilians, since it has the potential to create enough megawatts to power a small town. Experts point out that the nuclear reactor can also be used to create 20 kilograms of plutonium a year to power its nuclear weapons. To achieve complete denuclearization, the U.S. will have to persuade the North Koreans to give up not just their arsenal, but also facilities that produce nuclear fuel. Good luck and Godspeed to that. You sure?
Radiation still a concern decades after Chernobyl blast. 30 years ago today, an explosion tore through a reactor at the Chernobyl nuclear power plant in Pripyat, Ukraine. It sent deadly clouds of atomic material into the air and is considered to be the world's worst nuclear accident. Months after the Chernobyl blast in 1986, a concrete sarcophagus was built over Reactor 4 to contain the radioactive material inside. Years later, radiation is still present. Recent findings show milk from nearby farms contain a radioactive isotope 10 times higher than the allowed limit. The sarcophagus has since deteriorated, and engineers are currently building a giant stainless steel arch, more than 350 feet high and 500 feet long, to replace it. Called the New Safe Confinement, the 36,000-ton structure will be wheeled in place upon completion in 2017, effectively sealing the sarcophagus. Giant hover cranes in the arch will then disassemble and clean up the exploded reactor contained inside. More than 40 countries donated funding for the arch, which is expected to prevent further leaks for the next 100 years.
The ITER nuclear fusion project is 50% complete. More clean energy than needed by all of humanity? Yes, please. Construction on the International Thermonuclear Experimental Reactor in southern France has reached the important halfway milestone. Fusion energy looks to replicate the same process that powers the sun by converting hydrogen atoms into helium through a process that occurs at extreme temperatures. The reactor will have to be able to sustain temperatures 150 million degrees Celsius, 10 times hotter than the sun's core. The massive donut-shaped tokamak reactor will be surrounded by giant magnets that take superheated plasma away from the metal walls of the container. This requires the magnets to be cooled to negative 269 degrees Celsius. The ITER is aimed at using hydrogen fusion to create heat energy that can drive turbines to produce electricity.
Power up. NASA is testing a nuclear fission reactor prototype that could enable long-term stays on the surface of the red planet. The first humans on Mars will need to be able to generate power to transform the planet's water and carbon dioxide into liquid oxygen and fuel. Addressing this concern is the Kilopower project, a nuclear power system that comes with a uranium reactor core, which uses fission to generate electricity. The system can generate 1 kilowatt of electricity, which can power a toaster, to 10 kilowatts, which can light up to 100 light bulbs. 4 to 5 10 kilowatt units will be needed to power the Habitat charging vehicles, generate safe drinking water, and oxygen. The months-long testing for the Kilopower prototype began in November at the Department of Energy National Security site in Nevada. Though a flight test is at least 6 to 8 years away, if all goes well, the technology could be ready by the mid-2020s to early 2030s.
MIT says nuclear fusion is only 15 years away. Nuclear fusion could just be around the corner. Researchers at the Massachusetts Institute of Technology, working with a newly formed private company, say they will build a working fusion power plant in 15 years thanks to a new superconducting material that recently became commercially available. The material is a new superconducting steel tape coated with a yttrium barium copper oxide. The team, working with MIT spin-off Commonwealth Fusion Systems, plans to use the tape to make smaller, more powerful magnets that can be used in fusion reactors. The new magnets will double the magnetic field of a fusion reactor, which means more power can be produced with a smaller device. The smaller size will reduce costs and complexity, making future fusion power plants easier to construct. Limitless clean energy? But what about beautiful clean coal?